This resultant is the magnitude of the resultant vector. R is equal to square root of P square plus Q square plus 2PQ into cos theta. So if there are two vectors, two concurrent vectors acting with theta in between as the angle, then I can get the expression for the resultant of those two vectors. A vector describing the position and direction of a particle from the origin is called as a position vector. Hello students, welcome to this second session of chapter 3, Motion in a Plane. I am Madhu R from the Department of Physics at Vidhyaashram PU College, Mysuru, your Temple of Excellence. Let us recall what we did in the previous session. We studied about scalars, we studied about vectors. Why did we begin our study about vectors? Because to understand motion in two dimensions or to understand motion in a plane, we require these mathematical entities or operators called as vectors. What else did we study? We studied the type of vectors, the null vectors, the equal vectors, the negative of a vector, the unit vector, so on and so forth. We also studied about how we could operate vectors. We initially studied about vector addition, two laws that will help us to add vectors, the triangular law of vector addition and the parallelogram law of vector addition. We also understood that vector addition is both the commutative as well as associative. We also studied about subtracting two vectors and scalar multiplication of a vector, that is multiplying a vector with a real number. Let us move on and understand what we can do with vectors. Let us try to find the resultant of two vectors, okay, which are concurrent in nature. What are concurrent vectors? We studied in the previous class that any two vectors which have the same initial point, or if they start from the same point, then they are called as concurrent vectors. Let P and Q be two vectors acting at a point O. I have got two vectors, vector P and vector Q. They are acting at a point O and they are acting at an angle of theta in between each other. Okay? They are represented by the lines OA and OB of the parallelogram. They are represented by the lines or sides OA and OB. The diagonal of the parallelogram, which is OC, represents the resultant of these two vectors P and Q. So the resultant is given by P and Q, both in magnitude as well as direction, if you go back to parallelogram law of vectors. Let us draw a line CD. Okay, let us draw a line CD such that it is perpendicular to the extension of line OA. I will extend the line OA up to D such that CD is perpendicular to OD. Okay, so from the right angle triangle ODC, what do I have? Let me check. This is O, this is D, this is C. From the right angle triangle, what can I do? Let me take the Pythagoras theorem. The square of the hypotenuse OC square is equal to sum of square of other two sides. What are the other two sides? It is OD square and CD square. OC square equals OD square plus CD square. How can I represent OD? OD is a combination of two lines, OA and AD. So you have OD, we write it as OA plus AD. Now let me go to the other triangle, which is ADC. Okay, in triangle ADC, what do I have? I have an angle theta which is acting. Please remember, these are parallel lines. So this angle CAD will also be theta. Okay, what is the sine of angle theta? Sine of angle theta is opposite by hypotenuse. What is opposite? It is CD. What is hypotenuse? It is AC. So CD equals AC sine theta. CD equals AC sine theta. Similarly, the adjacent AD will be AC cos theta. Let us keep this aside. We will require this. Okay. Coming back to our equation, we have OA plus AD whole square. Let me expand this. Please remember, this is A plus B whole square. What is a plus b whole square? It is a square plus 2ab plus b square. So this is OA square, 2 into OA into AD plus AD square plus CD square. Please observe this. This is AD plus CD. Okay. This is AD. This is CD. From the triangle, once again, from the triangle ADC. Okay. If I take the Pythagoras theorem, AC square is equal to AD square plus CD square. Okay. So instead of AD square plus CD square, I can write it as CA square or AC square. Okay. Similarly, here this side I have OA square. This is 2 into OA. Here I had AD. What is AD? AD is AC into cos theta. So I replaced AD by AC cos theta. Now rewriting all these things. What is OC square? Okay. The original diagonal of the parallelogram. This is the resultant. Okay. So resultant square is equal to, what is OA square? OA is P, OB is Q. Instead of OB we have AC. Okay. So OA is P square and CA square is Q square. And instead of 2 into OA into AC, I have 2 into P into Q into cos theta. So if I take the square root, I get the expression for the resultant. This resultant is the magnitude of the resultant vector. R is equal to square root of P square plus Q square plus 2PQ into cos theta. When is this? When you have two vectors acting like this with an angle theta in between. Okay, we have only found out the magnitude. Let me check what is the direction in which they act. Okay, if alpha is the angle made by R, please check, the resultant makes an angle alpha with the vector P. Okay, so if alpha is the angle made by R with P, then from the right angle triangle OCD, once again I have O, C and D. Okay, what do I have? Tan of angle alpha is equal to opposite side by adjacent side. What is the opposite side? CD is the opposite side and OD is the adjacent side. CD by OD. Okay. So what is CD? If I go to the previous slide, okay, we have written down that CD is AC sin theta and AD is AC cos theta. Please remember this. CD is AC sin theta. OD is OA plus AD. OD is OA plus AD. Okay. So we know that OA is P and AD is AC cos theta. So substituting, I get Q sin theta by P plus Q cos theta, or alpha is equal to tan inverse of Q sin theta by P plus Q cos theta. So I have got two expressions. One expression was for the magnitude, the other expression is for the direction. So if there are two vectors, two concurrent vectors acting with theta in between as the angle, then I can get the expression for the resultant of those two vectors. Okay. Let us go on and try to solve one numerical based on whatever we have expressed now. Two forces, 4 Newton and 3 Newton, act at a point making an angle of 60 degrees. So what do I have? I have this P or A to be 4 Newton and Q or B to be 3 Newton. And the angle in between them, theta, is 60 degrees. We have to find out the resultant. Let us go on to do it. So what is this? This is square root of, what is A? It is 4 square. What is B? It is 3 square plus 2 into A into B. So this is 2 into 4 into 3 into cos 60. Okay. What is this? This is the square root of 4 square is 16, 3 square is 9, 2 into 4 into 3 is 24, cos 60 is half. So what do I get? I get this to be root 37, or the resultant is 6.08 Newton. That is the magnitude of the resultant. Let us find out the direction of the resultant. What do we have? Alpha is equal to tan inverse of b sin theta by a plus b cos theta. So let us find out what it is. This is tan inverse of, what is b? It is 3 into sin 60 by 4 plus 3 cos 60. Okay, this is 3 into root 3 by 2. Sin 60 is root 3 by 2 divided by 4 plus 3 into half, because cos 60 is half. So what do we get? We get this to be tan inverse of 2.59 by 5.5. Okay, you get this to be, use your simple calculators please. Use your simple calculator and find out what is the value of this term. You get this as tan inverse of 0.4742. You can use your Clark's table to find out what is tan inverse of 0.4742. You get the answer to be alpha is equal to 25.2 degrees. Okay, so for two vectors 4 Newton and 3 Newton acting at an angle of 60 degree in between them, the resultant is 6.08 Newton and it is acting at an angle of 25.2 degrees with the horizontal. Okay, let us check what is the resolution of vectors. What do you understand by resolving? Resolution is this process of splitting up of a vector into two or more components. Why do I need to split a vector? See, suppose a vector is like this, acting at some inclination. What is the use of splitting it? See, this is acting in 2 dimensions. So what do? I split it in such a way that I find out the components along its y-axis and along the x-axis. If this is vector A, I can find its components along the x and y-axis. What is the use of doing this? This AX will be acting only in the horizontal direction and this AY will be acting only in the vertical direction. So effectively I will have two vectors which are one-dimensional vectors. Okay, so this makes my life easy for mathematical operations. Let us check. So the process of splitting of a vector into two or more components such that the component vectors combined together shall produce the same effect as produced by the original vector or the given vector. So I have to split it in such a way that if I obtain the resultant of AX and AY, I must go back to the same given vector. Okay. If a vector is resolved into two vectors, I want to split it into two parts. How? Which are mutually perpendicular. See, AX and AY are mutually perpendicular. Then these vectors are called rectangular components. So if I am splitting it in such a way that they are perpendicular to each other, then they are called as rectangular components. Okay. What is the example? I have got a vector A. How do I split it? In the x direction it is AX, in the y direction it is AY. If I want to express that in terms of unit vectors, I will write it as AX I cap and AY j cap, where vector AX and AY are the components of vector A along the x and y axis. I can also write this as, to find the magnitude, AX is A cos theta, AY is A sin theta. Okay, just find out the components, sin and cos components of the angle theta, you will automatically find. Okay, so this is cos theta, this is sin theta for AX and AY respectively. Next, mutually perpendicular components of a vector. Suppose if R is a vector, okay, if R is a vector, see this is vector R which makes an angle theta with the x-axis. Okay, you can draw a perpendicular from this point A to point P on the x-axis and one horizontal line Q onto the y-axis. Draw a perpendicular from A to x-axis and to y-axis respectively. What will this be? The line OQ represents RY, vector RY, or the component of R in y direction. OP represents the component of R in x direction. They are mutually perpendicular components of R. So, vector R is equal to Rx plus Ry. From this triangle OAP, okay, from this triangle OAP, sine of angle theta is opposite side is AP, hypotenuse is OA. So, this is OA, AP by OA. This is Ry by R, or this is vector Ry. Ry is equal to R sin theta, Ry is equal to R sin theta into j cap. Instead of writing a vector here, I can write the magnitude R sin theta and represent a unit vector which gives me j cap. So what do I have? In the y direction, the mutually perpendicular components Ry is R sin theta j cap. Similarly, Rx will be R cos theta I cap. Okay, so the two mutually perpendicular components of R are R cos theta and R sin theta. Is that understandable? Let us now understand what is a position vector. How to understand what is a position vector? Suppose I have a vector like this. Okay. I have a particle which is in this position. I draw a vector from the origin up to this point. So how do I say what is the position? This will be the x coordinate and this will be the y coordinate of this particle. Let this particle be. Okay. So how do I find it? A vector describing the position and direction of a particle from the origin is called as a position vector. Okay. In vector form, I can write vector R as x into I cap, y into j cap plus z into k cap. If it is 2 dimension, it is just x into I cap, y into j cap. Okay, so if it is 3 dimension, you can also add this k factor. The magnitude of this position vector is given by square root of x square plus y square plus z square. If you want to find the magnitude of this position vector, you can find it out that way. Now coming to a displacement vector. What is a displacement vector? A vector joining the initial and final position. Okay, suppose the movement is represented by this curve. I have, this is one position P1, this is another position P2. So this line represents the displacement vector. So that line which connects 2 points for the motion of a body is called as the displacement vector. How do I write it? See, this is position 1 and position 2. So suppose this was the movement of the body. What do we have? We have vector R1 which connects to position P1 and we have vector R2 which connects to position P2. Between P1 and P2, we have got the difference between these two vectors which is represented by delta R. So what do I have? R1 is x1 I cap plus y1 j cap. So if I take the components of this vector, this is x1, this is y1. Similarly for this is x2, this is y2. So for vector R2, it is x2 I cap plus y2 j cap. Delta R is given by the difference between those two positions. So this is R2 minus R1, which is x2 I cap, y2 j cap minus x1 I cap, y1 j cap. Okay, so if I take the differences, I'll take I to be common, x2 minus x1 plus y2 minus y1 j cap as common. What do I have? I have delta x into I cap plus delta y into j cap. This is delta R. So the displacement is given by delta R equals delta x I cap, differences between the x coordinates, and delta y j cap, difference between the y coordinates of the two positions where the body has moved from position P1 to position P2. Okay. Let us check regarding what is the instantaneous velocity and what is acceleration. Okay. Let us first check with what is the average velocity. The average velocity is defined as the ratio of displacement to the time taken. The overall displacement to the total time taken. Okay, it is given by V bar vector, which is V bar x into I cap plus V bar y into j cap. So that is the difference. What is instantaneous velocity? Mathematically, instantaneous velocity is the limiting value of the average velocity. Whatever average velocity we have taken, it is the limiting value of the average velocity as the time interval reaches 0. As delta t tends to 0, delta r by delta t, limiting value, that will give me instantaneous velocity. It is given by vector v is equal to d into r vector by dt, dr by dt, okay, where r is the displacement. Please remember, what is velocity? Velocity is the rate of change of position with respect to time. So this displacement will give me how the position changes with respect to time. Now moving on to average acceleration. What is average acceleration? It is change in velocity divided by time. We know that it is rate of change of velocity by time. So how can I represent it? I represent it by a bar vector is equal to a bar x into I cap plus a bar y into j cap. What is instantaneous acceleration then? It is the limiting value. Mathematically, I can represent it as limiting value of the average acceleration as the time interval approaches 0. So limit of delta v by delta t as delta t tends to 0, or a is equal to dv by dt. Please go back to the definition of acceleration, rate of change of velocity with respect to time. Okay. So by this we come to the end of this session. Have a wonderful learning experience. Thank you.